the earliest road signs were crude, a stick in the ground or a pile of stones marked a route. In the Roman Empire, stone posts were erected along roadsides at regular intervals, indicating the distance to Rome. Centuries later, stone marker systems gave way to wooden cross signs, pointing in several directions at once. The international system of road signs we know today came out of the first International Road Congress, held in 1908. The process of manufacturing a road sign starts with a computer. Governments strictly regulate the specifics of the design. The computer's specialized software guides a machine to cut the design on a sheet of film. Once the design is cut, workers carefully peel off and discard the pieces. What's left is a film stencil of the sign, in this case, a French stop sign. Workers inspect it for defects, then prepare a screen of polyester fabric that they'll use later to print the sign. They start by coating it with a thin layer of light-sensitive emulsion. Once the emulsion's dry, they place the film stencil, using vacuum pressure to flatten it and get rid of any creases or air bubbles. Then the screen is exposed to an intense 6,000 watt light for 7 minutes. This activates the emulsion on the lettering and area outside the octagon, what's not shielded from the light by the film stencil. This exposed emulsion hardens, plugging the minute holes between the screen's fibers. After rinsing, the results become clear. Elsewhere in the factory, workers cut the aluminium panels on which the signs will be printed. Using a punch press, edges are rounded and holes cut for the bolts that will later attach the sign to the post. The company name and year of manufacture are stamped on for warranty purposes. The panels are immersed in a chemical bath to remove grease and other residues, then rinsed and dipped in an acid solution that seals the metal to help it withstand harsh weather. Next, the aluminium panels are laminated with a film containing minuscule glass particles. This film will make the sign reflect in the dark when light hits it. Then the panels are cut to the final shape. Now they can finally print the sign. The process used is silk screening, although the fabric used isn't actually silk, it's polyester. The machine forces the ink down through the screen onto the panel. The ink penetrates through the open fibre holes of the octagon, printing the red background of the stop sign. But it can't penetrate through the blocked fibre holes of the lettering and the area outside the octagon, so those remain white. The freshly printed signs pass through a dryer at 66 degrees Celsius for 5 minutes. To produce street signs, workers first laminate aluminium panels with reflective film for the background colour. Then either silk screen the street name or apply self-adhesive reflective lettering. But it's back to the silk screening process for printing multicoloured signs. Workers print them one colour at a time. The printed signs go into an oven for final curing at 176 degrees Celsius. The ink is transparent enough not to block the reflective film underneath. Therefore, the entire sign, not just the lettering, is highly reflective. that maximizes the sign's visibility and minimizes the excuses drivers can come up with for not heeding it.
În câteva clipe, la un pas de moarte. Înghețați la 6.000 de metri. Iar de la 21, caiacul de sub ghețuri. La un pas de moarte.
Acest program a fost sponsorizat de Practică. Pentru ideile tale.
Penn și Teller, cei mai mari iluzioniști și comedianți, vă prezintă 6 supoziții adevărate și o mare minciună. Dar care dintre ele e cea falsă? Descoperă minciuna!